4.11, the equation of a line in standard form. So far we have always used the slope y-intercept form of a line. And that slope y-intercept form looks like this. Y equals m times x plus b. Okay, and so x and y are coordinates. They're ordered pairs. They are these points that are all on the line. So these are all these are all the points on the line. Okay, and m is our slope. And so I'm going to mark that here, slope, and b is our y-intercept. Okay, so let's do a little investigation. Let's graph each of the lines here using a table of values. So y equals 2x plus 6. So what we're going to do is, so if our look at our b value, that's the y-intercept, that's going to go down here when x is 0. Okay, and if we look at our slope, the slope is 2. That means our values are going up by 2 every time we increase our x. So from -6, we go up 2 to -4. Again, we go up 2 to -2. And going in reverse, we're just going to subtract 2. So here -8, and here we have -10. Alternatively, you can use the x values, substitute them in there, replace the x in there, and just solve, and just evaluate that right-hand side. Okay, so over here we have 4x minus 2y minus 12 equals 0. Okay, it doesn't look exactly the same as this one. What do we do? Well, let's substitute x equals -2, which is our first value of x here, and solve for y. Okay, so if we do that, let's do that. So we have the equation says 4 times x, so 4 times -2, then we have minus 2y, and then minus 12 equals 0. Okay, so 4 times -2 is -8, minus 2y minus 12 equals 0. Now this is just going back to reviewing solving equations. Instead of solving for x, we're solving for y. So minus 8 minus 12 is minus 20, so minus 2y minus 20 equals 0. I add 20 to both sides, so minus 2y equals positive 20. And if I divide both sides by -2, I'll have y equals -10. So there is my y value. So my y value can go up here, okay? And if you do the same kind of calculation for all of this, you're going to get the same table of values. Okay, so what do you notice? They are the same. Which form is easier to graph? Well, certainly the slope y-intercept form, because that's what we're used to doing. And it's set up that way to make it easy to graph. Okay, it's more practical. So let's graph this. Let's plot our points. So here we have -2 and -10, -1 and -8, 0 and -6, 1 and -4, 2 and -2. Okay, and then we just connect that with a straight line. Okay, and there you go. Okay, so for all these other points, do the same thing. Just substitute your x value and find your y value. Now, this form of the equation, when it's not mx plus b, it's called something else. It's called the standard form. So write that down here in our notes. Okay, so this form involves the same x and y as in y equals mx plus b, but we rearranged it in a different way. Okay, so some examples are like this. So it's always going to look like where you have a x and the y all on the same side of the equation. Then you have your constant value at the end. Okay, and this constant value is not your y-intercept. It's not b. Okay, there's no m and b in here. Okay, it's just a different form of the equation. If you're going to use letters, we're going to use letters that look like this: capital A, capital B, and capital C. And so capital A will be the value in front of x, capital B will be your coefficient in front of y, and C is your constant term. Okay, so all coefficients are integers here. So no fractions. All terms are on one side in order of the equal sign. And so the other side will always be 0. Okay, and the coefficients on the x term is positive. Okay, so this is what we call the standard form. So examples: express each equation in the form y equals mx plus b and identify its slope and y-intercept. So the idea is you might get an equation that's in standard form, and you might be asked to graph it. And to graph it, you can't graph it in standard form. You have to turn it into y equals mx plus b form. Okay, and the way you do that is to isolate y. It's like you're solving for y in the equation. Okay, so how do I isolate y? Well, if I choose to add 3 to both sides, I can remove the 3. If I also add x, subtract x from both sides, I can move the x over to the other side as well. So here I'm going to have, so these two go away. I have y. These two cancel, equals 3 minus x. And there it is. There's my equation of the line. Now we can just rearrange it so it's y equals mx plus b form. So y equals negative x plus 3. Just reverse the order of the terms there. And so that we can say that our slope is negative 1 and b is positive 3. That's our y-intercept. Okay, let's look at this next one. So I can now, okay, what about the x and the minus 6? Let's move those to the other side. So I have 2y equals positive 6 and minus x. And what I have to do also is divide both sides by 2 so that you can isolate the y value. Okay, so here these two cancels. Y equals, so 6 over 2 is 3, and I have minus 1 half of x. So x divided by 2 is what's left over, so 1 over 2x. Okay, if you don't quite see that, maybe I should do it this way. What if I said y equals, and I split this into two fractions, 6 over 2 minus x over 2. And I can do that, right, because it's common denominator. So then now you might see that 6 over 2 is positive 3, and this is just the same thing as saying, well, 1 over 2x, so minus 1 over 2x. And if you want to rearrange it, I can say 1 over minus 1 over 2x plus 3, so that our y-intercept, our slope is negative 1 over 2, and our y-intercept b is equal to 3. Okay, what about this one here? Okay, so let's subtract 6x from both sides, and let's add 15 to both sides. Okay, so what we get is minus 3y equals uh, 6x plus 15. Now I haven't isolated a y yet, and I can only do that if I divide both sides by negative 3. And so when I do that, I get y by itself on the left side. On the right side, negative 6 divided by negative 3 is positive 2. And don't forget the x. 15 divided by negative 3 is minus 5. And so slope equals 2, and the y-intercept equals minus 5. What about the other way? What about turning standard mx slope and y-intercept form into standard form? So now you have to move everything back to the left and make the right side equal to 0. Okay, so if I move everything back to the left, okay, I'm going to have positive 2x plus my y value there, and I have minus 1. Okay, and that's equal to 0. Okay, if you're more used to the way I'm showing you how to do the math, moving the equations, well, what I'm going to be doing, what you can do is just say, well, if I add 2x to both sides, and if I subtract 1 from both sides, I get all this in the left. So 2x plus y minus 1 equals, and these two become 0. Okay, make sure the x comes first, then your y, and then your constant term. Okay, so for part B, same idea. Let's move everything over. Okay, so I have minus 4x plus y and plus 3 equals 0. But I don't want the negative coefficient in front of x. Okay, I don't like fractions, and I don't like that negative coefficient in front of x. So what I have to do is multiply everything by negative 1. And if you multiply everything by negative 1, you get positive 4x. The signs basically change. So I have minus y and then minus 3 equals 0. 0 times negative 1 is still 0. Okay? So move the terms to the side where the x term will be positive. Okay? So always make the x term positive. And so for this one, I just said multiply, well, I should say it up here. So this one, multiply by negative 1. Okay? All right, so what about C? We have fractions for C. So let's move everything over like we just did. So 2x comes over, it becomes minus 2 over 3x. Move the minus 5 over 2 over, so don't forget I have plus y over here, and then this becomes plus 5 over 2, and that equals to 0. Now I don't want negative, so I have to multiply everything by negative, and I don't like fractions. So the common denominator, what's the common denominator? Well, common denominator between 2 and 3 is going to be 6. Okay, so if I multiply, if I turn everything into a common denominator of 6, this is going to look like minus 4 over 6x plus 6 over 6y plus 15 over 6. So multiply this fraction by 3 in the top and the bottom equals 0. Okay, and I can't, 0 is still 0. All right, so then what I do is, again, I have to multiply everything by negatives, so I change the sign. So 4 over 6x minus 6 over 6y minus 15 over 6 equals 0. And now I can multiply everything by 6 to get rid of the denominator. So it's like everything multiplied by 6, so I get 4x minus 6y minus 15 equals 0. Okay, so we wanted a positive x value and we didn't want any fractions. So find that common denominator and cancel everything out. Okay, little application question here. So I can spend $40 on iTunes. All the apps I want cost $3 each, and the songs cost $2 each. How many of each I can buy? And determine an equation to represent the situation. So let's use our variables. Let statements, guys. Don't forget the let statement. So let x represent the number of apps. Okay, and let y represent the number of songs. Okay, so $3 for each app, so 3 times x, and $2 for each song, so plus 2y equals, how much money am I spending here? $40. Okay, so my standard form equation is going to be 3x plus 2y, bring the 40 over, so it's minus 40 equals 0. And that ends this lesson.